So standard 11, welcome back in exercise 2.1 of sequences and series. In the first video we have done question 6, now question 7. Find the four terms in GP such that sum of middle two numbers is 10 upon 3. Sum of middle two terms is 10 upon 3 and their product is 1 and their product is 1. So what are the number solution? Let the four terms be a upon r cube, a upon r, ar and ar cube. See this, how to assume this. So now what is given? Find the four terms. That four terms are a upon r cube, a upon r, ar and ar square. What is the ratio that you will see? This upon this, a upon r upon a upon r cube. That is equal to a upon r into r cube upon a. So this cut and this will become r square. So see that in AP also we were using the difference 2D. In 10th standard we have done this. When the four terms we are using, the difference we were taking 2D. Here the ratio is taken r square. Okay. Now if the six terms are given, then the six terms will be a upon r5, a upon r, ar cube and ar raised to 5. This will be the six terms. So this way means that the ratio would be r square when even numbers are there. When odd numbers are there, the ratio is r, that is kept. As in, suppose in AP, 3 numbers. In AP, the difference we were taking D. In AP, 4 numbers. Difference was 2D. Similarly, for GP, 3 numbers, ratio is R. For 4 numbers, ratio is R square. So 3 numbers were assumed like this, a upon r, a and ar. These were assumed. Here, a upon r cube, a upon r, then ar and ar cube. This way we have to assume. If there are 6 numbers, then it will be a upon r raised to 5, a upon r raised to 3, because ratio will be r square. Then here it will be ar 1, 2, 3. Then ar raised to 3, and the last will be ar raised to 5. We should not be prepared only for a specific sum. For different sums, these are the 1, 2, 3, 4, 5 and one more 6 you can take. So this way we have to assume. So for 5 numbers also, what to assume that we can see. So hope that you have understood this much lecture. Now, first our assumption is there. Now what is there? Sum of the middle two terms is 10 upon 3. Sum of middle two terms is equal to 10 upon 3. Middle two terms, these two are the middle two terms. So A upon R plus AR is equal to 10 upon 3. Therefore, I will simplify this. How I will simplify? What is the LCM of the denominator? 3R. I will multiply each term by 3R. A upon R into 3R plus AR into 3R is equal to 10 upon 3 into 3R. This method is very important method. At a time, we will eliminate all the denominator. Take the LCM of the denominator and multiply each term by that LCM. What is the LCM? 3R. Multiply. This R cut. This 3 cut, 3 cut. So overall equation will be 3A plus 3AR square is equal to 10R. Bring this here. Therefore, 3AR square minus 10R plus 3A equal to 0. Now afterwards we will find the value of A if possible, and then we can see what we can do. There is another, and their product. Their product means the product of the middle two terms is 1. Product of middle two terms is equal to 1. That is given. Therefore, product of middle two terms, these are the two middle terms, A upon R into AR is equal to 1. Therefore, this R cut. Therefore, A square equal to 1, and therefore A is equal to 1. Okay. Why not negative? Because their sum is positive. Why not negative? Because their sum is positive. That's why we are not taking negative. Now what is this? A we have got. This is number suppose 1. So 3AR square minus 10R plus 3A equal to 0 from 1. Therefore, 3R square minus 10R plus 3 equal to 0. Put A equal to 1. Now this is the quadratic equation. 3 3 are 9. Find the factors of 9 such that their addition is minus 10. So 9 is equal to 9 into 1. Addition should be minus 10. So minus 9 minus 9 minus 1 is equal to minus 10. So that is the addition. Therefore, 3R square minus 9R minus 1R, these two factors, and plus 3 equal to 0. Therefore, what is common that I will search? 3R is common. So R minus 3 3 is 9. Minus 1 into R minus 3 is equal to 0. Therefore, R minus 3 into another bracket 3R minus 1 is equal to 0. Therefore, R minus 3 is equal to 0, or 3R minus 1 is equal to 0. Therefore, R is equal to 3 or R is equal to 1 upon 3. Now, find the four terms. These are those four terms. I will use this value once and this value once. So, I will start from here. Four terms are. This is my first statement. And I will put these values. This I am writing now. That is, A means what? 1 upon R cube. R is 3 cube, comma. 1 upon R means 3, comma. 1 into 3, comma. 1 into 3 cube. So that is, here when A equal to 1 and R equal to 3, these values I am using, these two values. So 1 upon 27, comma, 1 upon 3, comma, 3, comma, 3 cube is 27. These are the numbers. What is the ratio? This upon this. So it will be 9. Or, oh yes, 9. Now, or. Now I am using this 1 upon 3. A means 1 upon. R is 1 upon 3, its cube, comma. A upon R means 1 upon 1 upon 3, comma. AR means 1 into 1 upon 3, R is, comma. A 1 into R cube means 1 upon 3 cube. Here I will write when A equal to 1 and R is equal to 1 upon 3. So that is, or the numbers are, the terms are 1 upon 3 its cube means 1 upon 27. This 27 will go up and 27, comma, this will be 3, comma, this will be 1 upon 3, comma, this will be 1 upon 27. And answer you will write, answer, the terms are this one answer or this another answer. These are the two answers. Hope that you have understood this. Now the 8th question, find the 5 numbers. Question 8, find 5 numbers in GP such that their product is 1024 and fifth term is the square of the third and fifth term is the square of the third term is square of third term. So what are these numbers? Solution. Let the numbers be. Let the numbers be. What are those? A upon R square. Ratio what I have to take? This is odd. Means ratio I have to take R. A upon R, then A, then AR, then AR square. See, if 6 numbers, then I will write AR cube that way. Here the middle term, if this is odd, the middle term should be A and go on spreading here and there. Okay. This is the middle term. So here it will be A upon R, here will be A upon R square. So here will be AR and here will be AR square. This way you can remember. Now what is there? Their product is 1024. Their product is equal to 1024. Therefore, product is A upon R square into A upon R into A into AR into AR square is equal to 1024. Therefore, this R square cuts. This this R and this R cancel. 1, 2, 3, 4 and 5. So A raised to 5 is equal to 1024. So this should be also raised to something. And what that should be raised to 5. So I will search that. What is that? 1024. I will factorize this. By what I can divide? By 2 I can divide. 2 5 are 10, 2 1 are 2 2 are 2 to the 4 remains 1 1. 2 5 are 10, 2 6 are 12. 2 1 are 2 2 are and 2 8 are 2 6 are 4 are 2 3 are 2 are 2 16 are 2 8 are 2 4 are 2 2 are and 2 1 are. So these are how many? 1 2 3 4 5 6 7 8 9 10. So 2 raised to 10 it is. But I want is something raised to 5. So what I will do, I will make this group. Then this group. Then this group. And then this last group. See this. This is 4. 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 1, 2, 3, 4, 5. Adjustment. Therefore, A raised to 5 is equal to 4 raised to 5. Now, taking the fifth root. Therefore, A is equal to 4. Taking fifth root. So, hope that you have understood this. So now, I have got this A. Now I want R. So for that, there should be another condition. Fifth term is square of the third term. That I will write. Fifth term is equal to square of third term. Fifth term, what is that fifth term? 1, 2, 3, 4 and 5. AR square is equal to square of third term. Third term 1, 2, 3. A square. A square. Therefore, this A square I can bring here and R square I have the value. What is the value of R? I don't know. I have the value of 8. I will write here 4 into R square is equal to 4 square. Put A equal to 4. Therefore, R square is equal to, this is 16 upon 4 is 4. Therefore, R is equal to plus or minus 2. Because this is the square root of this. Ratio can be positive or negative. Okay. Now the terms are. The numbers are. What are those? A upon R square, A upon R, AR and AR square. This I have written. That is, A is what? 4 upon 2 square. Positive I am taking. Then 4 upon 2, comma. A 4, comma. AR means 4 into R is 2. I will write into only into 2, comma. AR square 4 into 2 square. When A equal to 4 and R equal to 2. That is, this is 4 upon 4, comma, 4 upon 2 is 2, 4, comma 8, comma 4 into 4. That is, 4 upon 4 is 1, 2, 4, 8 and 16. These are the terms. So now I will take minus 2 R equal to. The numbers are, that is, A means 4 upon R square means minus 2 square, comma. A means 4 upon minus 2, comma. Then A means 4 into minus 2, comma. A means 4 into minus 2 square. And here I will write when A equal to 4 and R equal to minus 2. That is, minus 2 square is 4. 4 upon 4, comma, minus 2, comma, minus 8, comma, here this is square. So 4 into minus 2 square is 4. That is 1, minus 2, minus 8 and 16. So these are the numbers. So what is the answer? The numbers are 1, 2, 4, 8, 16 or 1, minus 2, minus 8, 16. This is your answer for question number 8. Question number 9. Fifth term of a GP is x. T5 is equal to x. I am writing in the short, fifth term of a GP is x. Means I have written T5 is equal to x. Eighth term means T8 is equal to y. Eighth term is y. And the 11th term means T11 is equal to z. Verify whether y square is equal to xz. This I have to verify. So this I have already written now. So now solution, I will write Tn equal to, what is the formula? A into R raised to n minus 1. Therefore T5 is equal to, what is that? A into R raised to n minus 1 means 5 minus 1. Therefore T5 is equal to AR raised to 4. But the T5 is what? X. Therefore AR raised to 4 is equal to X. This is number 1. Similarly T8 is equal to AR raised to 8 minus 1 means 7. Therefore AR raised to 7 is equal to what? Y. Number 2. Now T11. T11 is equal to A into R raised to n minus 1 means 11 minus 1 will be 10. Therefore AR raised to 10 is equal to what? Z. we have to verify. We have to verify means prove. Prove y square is equal to xz. That I have to prove. So LHS equal to y square. That is equal to, what is y? AR raised to 7. AR raised to 7. Its square from 2. That is equal to a square, a raised to 14. Understood? A square, r raised to 14. That is equal to. Now I will split up this in terms of this AR raised to 4 and AR raised to 10. See this. AR raised to 4, this one part, into AR raised to 10. Am I right or wrong? See this. I want xz. xz. What is this x? Here I have written AR raised to 4. That's why this a square r raised to 14, I have split it. A into a square. R raised to 4 into r raised to 10, r raised to 10 plus 4, that means 14. So this way I have split it. So that is equal to, this is what? This is x. X. This is what? Z. From, here I forgot to give the number 3. From 1 and 3. Or otherwise, this is LHS equal to this, I will keep as it is. I will keep this as it is. If you are confusing in this, then what you will do now? Now, this I will give number 4. Now, RHS equal to xz. That is equal to, what is the value of x? AR raised to 4. Into, what is the value of z? Z, AR raised to 10. AR raised to 10. From 1 and 3. That is equal to a into a square. R raised to 14, this, all this multiplication means addition of the indices, r raised to 14. This is r. This is number 5. Now check this. This is your LHS, a square r raised to 14. This is your RHS. Therefore, LHS equal to RHS from 4 and 5. Therefore, what is that LHS? Y square. What is that RHS? xz. Is proved. Is proved, is verified, anything. So this was somewhat different sum. Hope that you have understood this. Do the practice. I am working for you in the late evening. It is now 9:45. I am preparing the videos for you. You also take hard work. Question number 10. If P, Q, R, S are in GP, show that. What is to show? P plus Q, comma, Q plus R, comma, R plus S, R also, light has gone. I will just arrange for the light. This is the rainy season. All of a sudden the light has gone. Now I have some emergency lights. So let us see that you can see it. I am arranging the focus and adjust for this question. On this question I will stop. Are also in GP. That I have to find, show them. This P, Q, R, S are in GP. So that their additions, respective additions are taken. They are also in GP. That we have to search. So solution. P, Q, R, S are in GP. This is given. Therefore, I will say next term upon the earlier term Q upon P is equal to next term upon the earlier term R upon Q is equal to next term S upon R is equal to, this is constant, the ratio will be same, is equal to R. But here also this small r, here also this small r, that is confusing. So I will say this is equal to R, common ratio. Therefore, so Q is equal to PR, see this, R is equal to QR, and S is equal to RR. Therefore, Q is equal to PR, R is equal to, at the place of Q, what is the value of Q? PR. So I will say Q means PR and this R, so this will become PR square. S is equal to, R means PR square, this PR square into R, so this will become PR cube. So this you have understood. What is this R? This capital R is the simple ratio. Okay. Now, if these are in GP, then their ratios will be constant. So what I will find is this upon this I will find, this upon this I will find, and if that ratio is also R, then they are in GP. Now, Q plus R upon P plus Q is equal to, this ratio I will first find. Next upon the earlier. Next upon the earlier. First upon this ratio, then this ratio I will find. That is equal to, what is meant by Q? Q is PR. Plus, what is meant by R? R is PR square. Upon this P. What is by P? P is P. Plus, Q means what? Q means PR. So that is equal to, in the above, PR is common. From this also and from this also. Here remains 1 plus here remains R. In the denominator, what is common? P is common. P into 1 plus R. This 1 plus R, this 1 plus R gets cancelled. This P and this P gets cancelled. And that is equal to R. So, Q plus R upon P plus Q is equal to R. This is your number 1. So now, I will take this R plus S and this ratio. R plus S upon Q plus R is equal to, what is the value of R? R is PR square, plus S. S is what? PRQ. PRQ upon Q. Q is what? Q is PR. Plus, what is R? R is PR square. PR square. What is common? PR is common. PR is common. What is remaining here? No, PR square is common. PR square is common. Here remains 1 plus here remains R, capital R, upon here PR is common. What is remaining? 1 plus here remains R. This 1 plus R gets cancelled. This P gets cancelled. R square upon R is equal to R. So, therefore, R plus S upon Q plus R is equal to also R. This is number 2. So, from 1 and 2, this and this is equal to R. Therefore, Q plus R upon P plus Q is equal to R plus S upon Q plus R from 1 and 2. If the ratio is same, then these are in the GP. Therefore, P plus Q, comma, Q plus R, comma, R plus S are in GP. Is proved. So I will give you some time for seeing it because the light is less. So I am holding the light near to the visibility so that you can see everything. Just see it. And I am forced to stop the video today because the light is not there. Actually, I was thinking to do 2 more sums and finish this lesson, this exercise. So, okay, anyhow, we have some work for tomorrow. Good night, all of you.